Hello and welcome to All Things Antares. My name is Mark Silverstein. In this episode, we're going to discuss hybrid performance, knots, kilowatts, and nautical miles. It's been almost 2 years since we've had our boat on the water, and we thought now would be a very good time to go through and provide actual updates on the performance of our hybrid boats on the water. We would like to answer such questions as, how fast can the hybrid motor? What's the actual realistic range to expect if you're motoring on your hybrid? Is it more efficient to motor with one or two electric motors? What happens if we motor with one diesel and one electric motor? Also, how long does it take and what is the most efficient way to recharge the massive 40 kilowatts of Victron lithium that we have on our boats? So these are the questions that we're going to jump into in this episode. So let me just give you a quick overview for those that still might be new to this whole parallel hybrid technology. On our boats, we still have two Yanmar 40 horsepower engines. In addition to that, we have two 10 kilowatt electric motors, and those 10 kilowatt electric motors are what can propel the boat under electric propulsion. Those same motors are also 6 kilowatts each of generation capability. So we have the ability then to generate a total of 12 kilowatts of power, DC power, back to charging the batteries or using those same motors for propelling the boat forward. They're in parallel, meaning we can run one side on an engine and the second side on an electric motor. So we have this ability to be able to mix and match the propulsion capabilities of this boat, giving us a lot of redundancy. Okay, before I get into the numbers, let me give you the baseline for the conditions that we had for these tests. We conducted the tests on a 2023 Antares hybrid. The wind conditions were optimal. We had anywhere from 3 to 8 knots of wind at roughly 60 degrees. We had zero current. We were in a canal heading north to Annapolis. We had no current to contend with, so we had very optimal conditions to get a very good baseline. In addition, we have the Hydroline 18-inch props on our boat, and those props are pitched at a 10. So that's the background on the conditions for these tests. Now, let's get into the actual data. We're going to first start with the hybrid details. So if you look at this chart, let me walk you through what we're looking at. On the left-hand column here, we have our units, 0 to 50. And on the very bottom, we have our speed over ground in knots. So first of all, let's look at the green line. The green line here is our single motor range. So as we're traveling, let's say here at 4 knots, we will have a range of, let's say in the high 30s, probably 36 or so nautical miles. And as we move down this line, of course, the faster the boat goes, the less range that we have. The dark green line is the performance metrics if we're motoring using both electric motors. Now, if we look at the blue line here, the blue line is time. So this gives us time in hours of running. So if we're traveling and using a little bit of power on one motor, we can go up to 12 hours at 3.6 knots on one electric motor. The dark blue line that you see here is the dual motor operating time, which of course will be a lot less because it's using twice the energy. And we only have, remember, 40 kilowatts of power on this boat. 32 kilowatts is our 80% depth of discharge. So that's a magical number for us. We don't typically want to go below 80%. And finally, we have the red line, and this red line is the single motor power. So this is the actual power in kilowatts that motor is outputting, and it gives us our speed. So basically here, if you look at the number 4 kilowatts, we're doing right about 4.2 knots with 4 kilowatts of power being put out by that single motor. And then of course the dark red line is the power output with 2 motors running simultaneously. So that's the summary of this, but let's get into the so what, and let me just walk through an example of the so what. Okay, so let's talk about a practical example. We're going to run the boat at 4 kilowatts. 4 kilowatts is going to be about 4.2 knots of boat speed. That 4.2 knots of boat speed is going to get us about 31 nautical miles of range. You can pull this data straight from this chart. Now, what happens if we go through and run 2 electric motors consuming a total of 8 kilowatts? At 8 kilowatts, our boat speed will be right around 5.3 knots and will give us a range of about 20 nautical miles. The difference, and here's the key part, the difference between running 1 electric motor and 2 electric motors is a 55% difference in efficiency. So it is for sure more efficient to run 1 electric motor and not be in a hurry. That's the takeaway. And if you do that, you're going to have very, very good range just using the electric motors on this boat. All right, so we're going to dive into this chart. This chart, again, is for the Yanmar 40 horsepower engines. And so if we look at this chart and we start first of all with the blue lines, the blue lines is the efficiency in nautical miles per gallon. And the light blue line is running 1 engine, the dark blue line is running 2 engines. So for example, at 4.2 knots, we are going to be able to run 5.7 nautical miles per gallon at 4.2 knots on this boat. If we look at the red lines are the operating time in days allowing for a 20% reserve in fuel on the boat. And then, of course, the dark red line is both engines. And so this just gives us the operating time in days, i.e. 24-hour days of running at lower speeds versus higher speeds. And then finally, we have the green line, and the green line is the fuel consumption in gallons per hour. Light green being one, dark green being both engines. And so you look at this chart, it looks like a bunch of spaghetti, a bunch of lines going all over the place, but these are actual results from our boat on the water, providing performance metrics based on our hull shape, the props that we're using. And so our owners can use this to be able to better plan how is their boat going, should their boat be performing based on RPMs, based on speed over ground and fuel consumption, all that kind of good stuff. So one of the big takeaways from this chart is 5 knots is about the most efficient that we can run this engine. It's not very fast, but again, we're talking about efficiency here. If you care about speed, this boat at wide open throttle will do over 9 knots. At around 80% power, this boat is going to be doing 8.3 knots at 80% power. So that's pretty good. I mean, 8.5 knots at 80% power is good. Wide open throttle over 9 knots with a 40 horsepower, 18-inch props on this boat. While we're talking about diesel engine efficiency, this leads to the big question we get asked a lot. What's the range of this boat with the fuel capacity if I had to just go straight? Well, we have 2 different scenarios to compare. Number one, at 1,500 RPMs, that's about 25% load, engine load on this boat. That is burning about 1 gallon per hour at 4.5 knots. That will give us a range of about 1,100 nautical miles on one engine at 4.5 knots. Now, at the same RPM, 1,500 RPMs, if I had to get there a little bit faster, at 5.5 knots, that's at about 25% load, it will take us about 700 nautical miles running 2 engines at 5.5 knots. So if time is kind of a little bit more important and still being efficient, you can go 680, 700 nautical miles on this boat. Now, if I want to get there quicker and run at a higher speed, let's say 2,000 RPMs at 50% load, we're burning about 1.2 gallons per hour. That gives us a range of about 940 nautical miles on one engine and 570 nautical miles on 2 engines. So hopefully that answers the question. This is based on real data that we have from our boats in the water. This is not hypothetical, and it at least gives a really good idea of what this range is. So the summary is anywhere from, if you had all the time in the world, about 1,100 nautical miles. If you needed to get on it and still do it reasonably efficiency, about 600 nautical miles. So those are the 2 ranges that you can think about on speed. 7 knots, that's 6.9 knots, 570 nautical miles. So we think that's pretty good, and we're pretty pleased with those numbers. So we're now going to jump in and explain to you diesel engine efficiencies. And this is going to be important for our conversation a little bit later on about comparing electric motor propulsion versus diesel engine propulsion and regeneration. So if you look at this orange chart, let me first explain the axes. So this axis, and this is showing us on the y-axis, the efficiencies in kilowatts per liter of a diesel engine. And the very bottom, going from 0.2 all the way down to 1, is actually the engine load, or the load of that engine. So the orange line here is the Yanmar 40 horsepower, which is what we have on our boats. And the blue line is comparing this to an Onan 7.5 kilowatt generator on a boat. So the first thing to talk about is this. If you look at a big takeaway here for this orange line is at about 40% of load, all the way up to about, let's say it's 70, close to 70% load. That is the most efficient load to run these Yanmars. We're getting over 3 kilowatts per liter of power running at that load. If you look below on that blue line, this blue line is showing you the load of the Onan genset. Now, we don't have a genset on this boat, and this genset conversation is important a little bit later on. But just to show you, the genset, the Onan 7.5 is a smaller sized diesel engine. It is less efficient, and it is a lot less efficient at lower loads until it gets up to close to 80% load, and that's when it's at its peak efficiency, versus in this case 45-50% peak efficiency for the Yanmar. And this efficiency conversation is important because now we're going to be talking about utilizing one electric and one diesel simultaneously. So let's get into that. So let's have some fun and go on a 28 nautical mile journey. One of those trips, we're going to be running one diesel at 1,800 RPMs and the second electric motor at 5 kilowatts. And then we're going to go through and run both diesels at 1,800 RPMs and compare the results and see which is more efficient. My question to you before we start is, which scenario do you think is more efficient? Running one diesel and one electric, or 2 diesel engines? Well, let's get into the numbers and let's find out. So in scenario number 1, at diesel plus electric, we are going to be moving the boat at 6.2 knots. with both diesels at 1800 RPMs, it will also be 6.2 knots. The entire trip duration is the same, 4.5 hours and 4.5 hours, with a boat speed, as I mentioned, of 6.2 knots. So then let's look at how much fuel did we consume on this trip. Well, we consumed 5.3 gallons of fuel when we used one diesel and one electric, and then we consumed 8.5 gallons of fuel using both diesels. So you look at that and you say, which one is the most efficient? Well, it's kind of a trick question. It's a trick question because it depends on how do you regenerate the additional kilowatts that were consumed, and those additional kilowatts that were consumed were 18 kilowatts. So even though we were motoring at 5 kilowatts, our net electric generation was negative 4 kilowatts. So even though we were running a diesel powering forward at 1800 RPMs, we still had a deficit of about 4 kilowatts per hour. That translates to 18 kilowatts. So somehow we have to replace and figure out the energy required to charge back that power, and we will do that and then compare the results. So the big question we have to answer is, what is the cost to regenerate that 18 kilowatts that we expended out of our battery bank while we were motoring? And the answer to that question is complicated. We're going to keep it simple, and we're going to focus on what it would cost to run the diesel generators on the hybrid to redeposit those 18 kilowatts. And there are two specific scenarios we want to look at: the regeneration and charging while we are motor sailing, the boat is moving and we're sailing and we're recharging, and then when we're on the hook with the clutch disengaged. And the answers are different. And the reason why they're different is because the diesel engines are more efficient at higher load, and when we're motor sailing, and we'll see this in a minute, it is actually more efficient to fill our batteries up while we're moving the boat motor sailing than when we're sitting on the hook just running the engine to recharge the batteries. So if we're going to be motor sailing, it takes about 2.7 gallons to regenerate a total of 32 kilowatts of power. That translates to about 1.5 gallons of extra fuel that we would need to put back into the bucket to charge back 18 kilowatts. So if we add up our numbers, 5.3 plus 1.5 gives us 6.8. Let's say it's about 7 gallons of fuel that we will have burned in total going through this scenario, where we burned 8.5 gallons running both the diesel engines at the same time at 1800 RPMs. Now, if we're at anchor and we want to regenerate while we are on the hook, that is the least efficient way to be able to put power back onto the batteries, because we're only running the engines at about 25% load. And remember back to that chart, these engines are most efficient at higher load, and higher load being in the high 40s to 50s. So if we were motor sailing, we're going to be in the 50, 60, 70% load range versus 25% load when we're on the hook. And so in this scenario, if we were on the hook, it is almost a wash. It's about maybe 8 to 10%. It's a little bit squirrely based on the number. 7.7 is 2.3 gallons it would take us to put that back into the battery, the 18 kilowatts, and it gives us 7.7 versus 8.5. I would call that closer to a wash, maybe a little bit more efficient, but there's a lot of inefficiencies with, even though we're charging DC to DC, there's still some inefficiencies in here. So I would say it's not dramatically more efficient, but maybe just a little bit. So that gives you some sort of an idea. So we do have options. The summary is we have options. There is no harm, no foul in utilizing the electric motor and utilizing your diesel, and you will probably gain some small benefit from doing that, especially if you intend on recharging when you're motor sailing maybe the next day. So our final conversation is, how do we efficiently recharge this very large lithium battery bank? What's the most effective way to do that, and what's the cost to do that? So let's look at this. And again, this is based on actual data that we have from our boats. We surveyed several different hybrids that were on the water. We compared notes, compared metrics, and averaged the efficiencies that these different boats were having on recharging their battery banks based on different scenarios. So we know that this data is as close to correct as possible. Certainly there can be some variables from boat to boat, but it will at least give you a pretty good idea of what's happening. And so we have some assumptions. I'm going to walk you through those assumptions first. And the assumptions are the cost per gallon. In this case, we use about $4.50 per gallon of diesel fuel, US dollars. The marina cost per kilowatt charge we based on an average of a couple different marinas on the East Coast. It was about 30 cents per kilowatt, depending on what marina you go to. So in general, we just wanted to have some numbers to work with, because here's what's important. If we look at marina power, it will cost us about $9 or $10 to recharge 32 kilowatts. And again, we're talking about replacing 80%, that's 32 kilowatts of lithium power on this boat in this scenario. You're effectively fully discharged to 20% depth of discharge. It's $10 to go through and recharge on marina power, and that will take you 10 hours to recharge plugged into a pedestal. If we were hybrid if we were generating power and charging while we were motor sailing the boat, it would cost us about $12.3, roughly $12, and it would only take 3 hours to charge back that 80%. So in 3 hours time, at a cost of about $12, we can then regenerate and charge back those 32 kilowatts of power. The difference between motoring and anchored, as I mentioned before, are the efficiencies that we're gaining with the boat already having to expel fuel to propel the boat and turn the prop. And so there's definitely efficiencies that were gained in doing that while we're motor sailing, and you can see that in these numbers. And these numbers, as I mentioned before, are actual numbers that we did testing the boat motor sailing, testing the boat at hook with the clutch disengaged. I was surprised at the differences in numbers, but the explanation, as I mentioned to you before, are the power band and the efficiencies of these engines at higher loads for recharging, in this case, and recharging the batteries. So anyway, at anchor, it's about $20, and it will take us, again, 3 hours, $20 to recharge. We thought it would be fun to go through and look at a traditional genset. So let's just say that you didn't go hybrid and you still had the same batteries to recharge. How efficient, how long will it take you on a genset with 2 Victron Multipluses to recharge these batteries? And the answer is it's almost the most expensive way to recharge these batteries. It's $22, $23 to recharge the batteries, and in addition to that, it's 15 to 20% more than if you were on the hook, and it will take 10 hours. So it takes 3 times as long to recharge that battery on a genset going through 2 Victron Multipluses versus doing it with both of the electric DC chargers, the 6 kilowatt chargers that are on the boat. So then we said, okay, well, just for fun, let's look at what would it take to recharge these batteries if you just had alternators. You just had your alternators and you weren't running your generator and you wanted to recharge 32 kilowatts. That is going to cost you, on dual 100 amp alternators, that will take about $33 to do that, and will take 11 hours. So that is the least efficient, most expensive way to recharge your lithium batteries, is using your alternators. The next least efficient is a diesel generator. And again, this is going from AC to DC. This is not a DC generator. This is an AC to DC going through your Victron Multipluses. And then you get into anchored is next on the hybrids, and then motor sailing, and then of course marina power. So the summary is the cheapest way, of course, to repower everything is using solar, but the problem is you need, a ton of solar, like 5 to 6 kilowatts of solar, to make that meaningful. And there just isn't enough real estate on our boats to be able to put that much solar on board. So on my boat, I have 3.1 kilowatts. It works great, but I would have a long time before I would be able to recharge that much power unless I keep and was very frugal on my use of power. And we need to answer the fundamental question: is the parallel hybrid system worth it? And the answer is yes. Sarah asked me the question as I was preparing for this. She said, Mark, do you wish that we had a hybrid? And I immediately answered, absolutely. And here's why. Number one, the lithium capacity on these boats is substantial. Why that's important is because it means that having 40 kilowatts of power when you're living off the grid, on the hook, and in remote places gives you a lot of energy to be able to live comfortably when you're on the hook. And comfortably, I mean running your air conditioners at night, cooking on your electric cooktop stoves, and doing lots of other things that you normally would not be able to do very easily using electric power. So that the bigger the battery capacity, the longer that I'm going to be able to live without having to run a diesel generator to recharge that. But solar panels and solar power, while being free, the reality is it is difficult to be able to recharge that much lithium in a reasonable amount of time. And this is the key part. 3 hours. 3 hours running 2 diesel generators to recharge 32 kilowatts. That's not 10 hours, it's not 12 hours, it's 3 hours to do it very quickly. And so that is an amazing advantage to be able to, and also, by the way, not have another diesel engine on board, which is a genset, to be able to charge, because as we saw, alternators are very inefficient at charging this much lithium. It will take you a long time and cost you. It is the most expensive way to recharge these batteries. So that is a long-winded answer on those pieces of the puzzle. But then we also have, of course, redundancy. So we have the ability to be able to be purely electric, and hybrid, as we mentioned before. And I have this peace of mind knowing that I have different combinations of how I can use my boat to be able to get me from point A to point B, and maybe even get me out of a situation that might be more complicated if I had an engine failure on one side or the other. In particular, docking a boat in a marina on one engine is very difficult on a catamaran. We have not had a chance to dive into hydro regeneration in this video. We intend to do that in the future, and that is another advantage of a hybrid type solution, especially if you're a blue water sailor and plan on doing some real passage making. It's not, frankly, as important if you're going to be doing day hopping and day sailing, because you're going to go from point A to point B. You know, it does slow you down. It slows you down a knot, maybe more, depending on what you're trying to do. We'll talk about those details later, but that is also an advantage of this hybrid technology. And so finally, let me just dispel the rumors, or just not the rumors, but the conversation about, oh, this is a new technology, Mark. You know, I don't want to be on bleeding edge, leading edge, whatever. The reality is it's not. This has been around for over 15 years. We are a very conservative builder, as most of you know, and that's also in how we design our boats. And we want to make sure that these boats are going to be dependable and safe for a family sailing anywhere in the world, or a couple. And so this technology that we selected has been around for 15 years. And so that has given us peace of mind, knowing that we're not on the bleeding edge of technology deploying this out to our customers. We've made a lot of improvements over the last 2 years. We've worked with other boat builders to improve this technology, to make it more efficient for all of us as sailors. And we're excited that we just have this community to be able to work together to make hybrid solutions, no matter what the boat manufacturer is, more available to customers. I believe in it very strongly, and I feel like that it's just very gratifying to see so many other boat builders also, you know, jumping onto the parallel hybrid system. And we have, of course, a lot more to be talking about in the future around parallel hybrid technology, and we look forward to doing that at some point. Thank you very much for your time.